A brief history of solar cell. Actually, one of the important technology used today is solar cell, and you may ask about the history or the present situation or the future of solar cell. This discussion gonna take you in a brief to the full picture of the solar cell for publics. I'm not gonna go deeply in scientific, but simply the idea of solar photovoltaic effect started by Becquerel in 1886, talking about more than 100 years back. And then in 1905, Einstein explained this effect, the photovoltaic effect, and he won Nobel Prize, by the way, based on this explanation here, not for relative theorem. And then later, around 40 years later, Bell Lab, they manufactured the first silicon technology with 4% efficiency. And I will say something about efficiency later on. This is in 1994. A few years later, it has been used by humankind. The first satellite sent to the space, which is called Vanguard by the US people. And this is one of the scientists who participate in this project. You can see here the seal in this satellite. I'm here handling the fifth version of this satellite, and the increase in production of this technology, talking about thousands and hundred thousands of mega by many countries. This is all data talking about the world PV production or the solar. By the way, solar cell or PV are the same here, as I will explain. And seems to be there is growth, and there's like a lobby, and countries are competing. China take over today, and this is the accumulative installed PV power. Talking about gigawatt, you can see here it's more than 500 mega in 2018, and it's going up with time. Now the efficiency is increased. You can see here in 1975 up to 2020, the efficiency going up by different technology. These colors mean different technology. You may say, okay, why the efficiency is still here less than 50%? Because simply the solar radiation coming from the sun, the spectrum here, as you can see here, only the visual part to be converted into electricity by solar cell. The cell is the small, let me say, device. When we put it together in series and parallel, we come up with a model. When we put with two in series and parallel, we come up with the array to increase the power, energy, and so on. Now, the material used to manufacture this cell is the silicon, which is the second element available in our nature. As you can see here, the yellow one. Then silicon is part of the applied research, not the basic research, and many of technology today is using silicon. And simply, we have silicon ingot after we manufacture it through the line process. Then we cut it in the over slicer, and then we have the cells. We put them in series and parallel to have a panel. We cover it by glasses from the top, from the front, and we put it in different shape, different colors, because we have different technology and different way of manufacturing. And we put insulator behind, and then the frame. We have full process, okay, starting from the raw material to the solar cell to the sorter to the assembler, laminators, and simulator to test it, and then we have the model. Now, simply, just in brief, we have the silicon. In the silicon, we have two elements. Let me say elements. We have the conduction band and valence band. When we create electrons, free electrons, and jump from the valence band to the conduction band, then we have electrons. How we do this? Simply by doing impurity, by putting impurity, doping impurity. This impurity could have either 3 electrons in the outer band or 5 electrons in the outer band. So we come up with either an N-type, which is negative, or P-type, which is positive. When we put them together, we come up with a sandwich. We call it p-n junction. This p-n junction represents the cell. Now, this cell, simply when the photon came, give energy to the valence band to create exciton, which is electron hole pair, electron jump to the conduction band, then we have electrical current. We collected by these pass parts and fingers, and then we have terminals coming out from the cell. Now, the cost of this technology is not high. It's going down with time. As you can see, it's less than $1 per watt, comparing with 50 years back, to between $70 to $80 per watt. Many applications, starting from small applications using this cell, solar cell, for kids, going up to application for lighting, lamping, power screen, use it for workers, and for many other applications. Wide range. You cannot summarize it here. and then it start to be used for in stations, for houses, for campus, as you can see here, or for cities, generating electricity for cities. As you can see, many countries using this to generate electricity for, as example, Germany, Spain, Portugal, UK, US, Australia, China, and so on. Now, also, the line production of this technology is available today and it's cheap. It can manufacture up to more than 1 gig. As example, this line production you can see here, it's the size here is 5.7 square meter, which means 1 Yao Ming by 1.12 Yao Ming. And then this technology start to be part of the many countries' plan and visions. United Nations are leading in this, and many countries put this in their vision. As example, solar vision, they call it solar vision in 2030, 2040, 2050 by many countries beside other renewable energy to share the energy profile. Now the message could be sent here is solar voltaic is real in the past, today, and tomorrow. Investment in policy and research development is priority. Reducing the gap between lab and the market is important. More funds need to be given here to increase the technology and improve it and balance research development profile. Now, let me conclude here. The only thing about the future that you couldn't predict was the history you didn't know, but it is easier to grasp the future if you know what it should look like, and the best way to protect the future is to create it. Please use solar cell. Thank you.